What's cooking good looking, guys? I'm Akif. Here with me is Ryan, Rifat, and Chen Si. Yeah, and today we're gonna present to you our queue time tracker. Okay, so this is our table of content that we'll be showing you. So in this presentation, we'll tell you about our project introduction, research and background, hardware use, block diagram and flowchart, MicroPython coding, this implementation, and the challenges and improvements we have faced and overcame together.
Okay, so for our project introductions, it's more of like why we think that the queue time tracker is needed and how does it work. So for queue time tracker, our queue time tracker are there to let customers know how long more they have to queue. Therefore, they can decide whether they want to continue shopping or they want to go and start queuing. Next. Our driving questions are how do we improve the efficiency of counter to make it more systematic? Thanks.
Now on to research. The first slide shows that customers want high quality service experience, while businesses and companies want low cost to serve. Our m5Stack hopefully aims to find a middle ground where it will make both the company and the customer happy. Next slide. In the next slide, it shows that customers want their experience in the retail stores to be seamless, to be smooth. Our project hopefully aims to make their experience smoother and will hopefully make their experience less negative. Next slide. Lastly, in the last slide, it shows that customers will also get frustrated if they experience disruptions and have to wait even longer, and if they don't know their wait times. So again, our project will have a RGB sensor to tell them and to inform them the wait time. Next slide.
Okay, so this is our hardware use. So in this project, we use two m5Stacks, two PIR sensors, and one RGB unit.
So now I'll be showing you the block diagram and flowchart. Next slide. This is our block diagram that shows the inputs and outputs the m5Stack will be using and doing once the code is run. Next slide. This is our flowchart, which shows what the code will be doing once it starts running. Next slide.
So I'm going to share with you our MicroPython coding that we have done. So I've done the transmitter code and Rifat has done the receiver code. So the transmitter code is very simple. I'm going to explain it in a very short way so that everybody can understand. So basically, we have connected this transmitter m5Stack to the same Wi-Fi protocol, so it'll be easier for ASP.NOW and MQTT to communicate with each other. So basically, what we have done is we have created our own timer. So basically, when the start of the IR sensor senses a person, it returns a true value, and the timer will start. And when the NPIR sensor senses somebody and it returns a true value, it will stop the timer. Then the values in the timer will be appended into a list, and we can find the average time taken for one person to complete their shopping, their payment. And then we will publish it to MQTT, Cubitro, and ASP.NOW to the receiver m5Stack.
Okay, so this is the receiver code that I've written. Okay, so once the data is sent to the receiver by ASP.NOW, it will then be put into compared to a set of conditions such as if it's less than 8, it will fetch green and the text will change to smooth. Then if it's greater or equal to 8, it will then fetch red and the text will then change to congested.
Okay, so this is our design implementation. So it's the same as a block diagram. So the transmitter m5Stack is connected with two PIR sensors in port A and B, and this is the UI that we have created. So in the UI, you can see the time taken, and you have a reset button and another text that says starting to see if it's connected to Wi-Fi or not. Alright, and then whatever data is taken is sent to the receiver m5Stack through ASP.NOW, and you can see the average time, and you can see the queue is short, smooth, or long and congested, and it will show green and red respectively. Yeah, and the data is also sent to Cubitro through MQTT and is put in a graph so it will be easily readable for managers to analyze. Yeah. So this is how it will be implemented in real life. We have two IR sensors at the start and the end. The MQTT, the m5Stack transmitter in the middle, and it sends the data through ESP now to the receiver m5Stack at the top, and it will show red or green for the customers to see.
Okay, so this is our phone board design. Okay, for the top left, we have the problem statements and all. Why do we need our queue time trackers? Yeah, then for the top right is a real life example, a small example of how our things will work. And the bottom left will be a cartoon of what we used, and bottom right will be how it display on Cubitro. Next.
Now, for the challenges and improvements, firstly, we had to find a suitable solution for this project, which was the first challenge. And the second major challenge was the connection of IoT, because we realized that certain internet providers like M1 could not connect for some reason. Next slide. Now, for the future improvements, we can potentially integrate our system into apps. Like, for example, if IKEA has an app, they can check the queue times from their smartphones and not have to look up constantly. Secondly, we can implement machine learning to further decrease the manpower needed to analyze the graphs. And thirdly, we can enhance the security of the IoT system. Thank you.
Thank you for listening to our presentation, and now we'll show you our demonstration.
Okay. So this is how our project demo will be like. Rifa will act like a customer, Ryan will be the cashier, and that's the start sensor, this is the end sensor. Okay, let's begin.
So as you can see, the light here turns green, and the average time is calculated here. It also says the customer flow is smooth, and it's green.
Here also will show the time taken for each customer.
Thank you very much.
Thank you.